What is nodal analysis? Nodal analysis is used to analyze the circuit. What is nodal analysis? Nodal analysis, the name itself says node. Node means a point. Which point it connect multiple branches or multiple wires to a single point. Then it is called a node. Nothing but a junction point. A junction point. Simply, many wires connected to a single junction point is called node. Let us see working of nodal analysis. What is working? How to apply this nodal analysis to the circuit to get a required one. In working, first you should identify number of principal nodes in the network. Again, node is nothing but a connection of more than two wires. Two branches. Identify number of principal nodes in the network. So what is principal nodes? So this is one node because here this node is connected to three branches, 1 2 3. Again, if we observe, this is also one node because if we redraw or if we remove extra wire which is connected to this, then the redrawn circuit look like this. So it is also one node. So here in this circuit we have two nodes. So this is also one node. We have two nodes. Now consider a ground voltage. So make this as reference node. So connect that reference node to ground voltage. So this is connected to ground. So now assign reference node with respect to ground. So now write the nodal equations or KCL equations. So third point, by using this write nodal equations. So it is combination of KCL plus Ohm's law. So what is the question he asked? Find the value of V1 in the below circuit using nodal analysis. So we want to find V1 in this circuit using nodal analysis. We may solve this circuit in two ways, such like method 1, along with current flow direction, or method 2, current flowing away from the node. So if we redraw the circuit, along with the current flow direction, what is the flow of current? Here current flow from positive terminal. Also from the source, current flow from positive direction. So current flowing like this. So current entering at V1 from positive volts and leaving through this 3 volts terminal. So leaving like this. Here current flows in this direction. So if we apply KCL at node 1, there are these currents I1, I2, I3 as names. What is KCL? KCL is sum of current entering to the junction, which is equals to sum of current leaving from the junction. So what is the current entering to this point, which is equals to I1, which is entering, leaving from I2 and I3 currents leaving. So we don't have I values, so we are taking Ohm's law. What is Ohm's law? Is equals to difference of voltages by resistance. So now I1 equals to 5 minus V1 by 2 ohms, which is equals to I2. I2 is equals to V1 minus of minus 3 volts. Here we have minus 3, here I have plus 3 volts, the potential difference. So minus of minus 3 by 4 ohms plus I3. I3 is equals to V1 minus ground voltage, which is 0 by 8 ohms. If we take LCM, then 2 comma 4 comma 8, 2 has 1 comma 2 comma 4 by 2, 1 1 2, 2 into 2 into 2 into 2 4, 4 into 2 8. So we get 8 as LCM. So write this equation in denominator as 8, 8 plus 8. Here 2 into 4 8. So 5 4 ja 20 minus 4v1, which is equals to 4 into 2 8. So 2v1 minus into minus plus 3 2 ja 6. Here v1 cancel out 8 on both sides. So we are left over with 20 minus 4v1, which is equals to 2v1 plus 6 plus v1 plus 2v1 plus v1, which is equals to 3v1 plus 6. Here 20 minus 4v1. Taken come v to one side and constants to other side. So 20 minus 6 equal to 3v1 plus 4v1, which is equals to 7v1 is equals to 14. So v1 is equals to 14 by 7, which is equals to 2. So v is equals to 2 volts. From method 2, current flowing away from the node. So taking current flowing away from the node. If you read out the circuit, so taking current flow direction as away from the node. So away from the node. Now apply KCL at node 1. If we name the currents, then let this as I1, I2, I3. From KCL, sum of current entering the junction is equals to sum of the current leaving from the junction. So here sum of the currents is entering the junction is 0 and leaving from the junction is I1 plus I2 plus I3. We not have the values of I currents, so we are taking I equivalent. I equivalent is potential difference by resistance. So if we rewrite this one, so I1 plus I2 plus I3 equal to 0. What is I1? I1 equals to V1 minus of 5 by 2 ohms plus I2. I2 is equals to V1 minus of here minus 3 volts plus 3 volts minus of minus 3 by 4 ohms plus V1 minus ground voltage which is 0 by 8 equal to 0. Here if we take a common denominator, then we are going to get 8 as LCM. So V1, so 8 plus 8 plus which is equals to 0. 2 4 j 8. So 4V1 minus 20, 4 2 ja 8. So 2V1 minus into minus plus 3 2 ja 6. Here simply V1. Take and go the denominator to RS side, which is going to cancel out. So we are left over with 4V1 minus 20 plus 2V1 plus 6 plus V1 equal to 0. If we write V1 as common term, then 4 plus 2 6, 6 plus 1 7, 7V1 again 20 minus 20 plus 6 which is minus 14 equal to 0. Then 7V1 equals to 14, V1 is equals to 2 voltage 2 volts.